Um, Now we come to our last application of electrolytic cell. Then we close the cell and we move to something else. Okay, this is electrolysis of concentrated sodium chloride, which some people call brine. Now, this is the layout. Inside this one, we have our concentrated sodium chloride, our normal table salt. These ones are graphite electrodes. And we need to remember that if you put the external circuit like that, it means that this one, which is attached to negative, is our cathode. And this electrode, which is attached to positive, is our anode. And you have to remember that the ions which are contained in our sodium chloride are sodium ions and chloride ions. And when you go to the mechanism of conduction, it's the same mechanism we know. The cations move to cathode and the anions move to anode. So these are the cations. They move to cathode. And these are our anions. And they move to anode. So C move to C and A move to A. Is that okay? So now when they reach their destinations, they undergo chemical change. And this chemical change, we saw part of it before we reached this stage. Let us see what happens. Now, let us start with the reaction at anode. If you can recall the ion, which ion moved to anode? Our anion. Our anion was the chloride ion. So chloride ion moved to anode and attain this status. It becomes oxidized to chlorine gas. When you balance this, then you know how many electrons are involved and you put them here. That's the reaction which takes place at what? At anode. This gas, chlorine, is going to be formed there. So what reaction occurs at cathode? Reaction at cathode. I told you this in the videos before. So this was the scenario. What do you have here? Remember the ion which moved there. It's sodium ion. But there's something you have to remember. That sodium chloride is dissolved in water. So water is also another participant here. So these two are going to compete for cathode. And we did this one before. So how do you deal with this situation? You first come to cathode and say, what reaction occurs at cathode? Okay, it's reduction. So it is a reduction reaction. Reduction reaction. Okay. So then when you look at this reduction reaction, you have to know and go back and check that the compound which undergoes reduction must be an oxidizing agent. So the question is, between sodium and water, which one is a stronger oxidizing agent? So there are two ways of doing it. You can use the values of the standard reduction potentials, or you can use the relative position of the of these two, water and sodium. So let us look at the values. The one which is a strong oxidizing agent, which is supposed to undergo reduction, must be at the bottom. Oh, look at the table. I'm using now the relative positions. At the top, we have strong reducing agent. At the bottom, we have a strong oxidizing agent. So the one which is more at the bottom is the one which is most likely going to win the race. And do you know what it is? It is water. When you look at the table, our table 4B will check water is at the bottom. So it's a stronger oxidizing agent compared to sodium. And what is going to happen to water? This is what is going to happen to water. Water is going to undergo a reduction. So two water molecules take up 2 electrons to give you hydrogen gas and the 2OH ions. If you have a problem with this reaction and you find it so complex, go to the table 4B and take it from there. But you have to remember that this sign must not be reversible. I think there's one of the video where we messed up and we made it reversible. This sign must be a one way. So if you have a problem with this reaction, use the table 4B. It is there, well written. So this is the reaction. Okay, let's go to the, supposing you decide to use the values of the standard reduction potential. Which one is going to be a stronger oxidizing agent? The one which is more positive. And guess what? It is again water. So in other words, water wins the race, and it's the one which is what? The one which is reduced. Our friend sodium becomes just a spectator. Now, if they ask you, why water? Why water? The reason is the same reason we've been giving. You are going to say water is a stronger oxidizing agent than sodium. So it undergoes what? Reduction. Now we come to net reaction. Let us look at the net reaction. The half reaction at cathode, it was actually the half reaction at cathode. Which one? It's 2 water taking up 2 electrons to give you hydrogen gas plus 2OH minus. The half reaction at anode, it was chloride ion becoming oxidized to chlorine, and that's the reaction we had. So when you look at these two reactions, Getting net out of it requires you to cross out these electrons, and you remain with 2 water plus 2 chloride ion, giving you H2 gas plus Cl2 gas plus 2OH minus. So this is the net. Now, this net has something to say. Let us talk about this pH of the medium above. So when this reaction proceeds, something important happens. I want you to take note of this. The accumulation of hydroxide ions. The hydroxide ions have a very big implication on the pH. They make the medium basic. So what will happen to the pH? The pH of the resultant solution increases. Or we can say, if that one is too technical, we can say medium become basic. Okay. Now, this setup we see here, it shows us what we observe at the end of this this cell, at the end of the functioning of this cell. At this cathode, we get hydrogen gas. Remember, coming from water. And at this electrode, we get a greenish yellow gas. Which is chlorine. Coming from what? Coming from sodium chloride. So this is one of the cells where 2 gases come out to be the product. On one electrode, hydrogen is formed, that's the cathode, and on the anode, chlorine gas is formed. Okay. Now we conclude electrolysis of concentrated sodium chloride by observing how it behaves in a membrane cell. This setup here depicts a membrane cell. What you have here between the 2 half cells is a semi-permeable membrane, meaning that it allows some material to go through and restricts others to go through. So this side we have our electrolyte, which is concentrated sodium chloride. It enters here. What comes out of here is a spent sodium chloride. So what happens is that out of whatever happens here, there's only one ion which is important to us, which crosses this, and this ion is sodium ions. Now, during the time when Menelanas were being taught, we used to tell them that this one can even tell you the polarity of the electrodes. Because if they are positive, they are moving to the other side, it means that this side is positive. And where they are going is what? Negative. Using the mechanism of conduction, where positive move to negative and negative move to positive. Now, this side, what enters is water. And what goes out of this one is sodium hydroxide. What comes out of this one, sorry, what comes out of this one is the chlorine, which breaks out of this one, and what comes out of this one is hydrogen. Now, when you look at this setup actually is, I was told it's being, this cell is carried out by Sasso, and for purposes of getting these products, they get chlorine, they get hydrogen, they get sodium hydroxide. Those are the three products which are obtained from the membrane cell. The reaction at anode and cathode is the same as before. Now, the onus is on you to know what these products are used for. Now, the three products which are coming out of the membrane cell, very clear. We said one is hydrogen. And what is hydrogen used for? It has so many applications. One is formation of margarine. The process is called hydrogenation. The other one is used in the blowtorch for welding. Okay. Then what other product do we know? We know chlorine. And where do we use chlorine? Chlorine, we use it, one, formation of bleaching agent, like jig, Domesto, and others. So it's used in the formation of bleaching what? Agents. Where else can we use chlorine? A purification of water. Okay. Then there's another product, which is what? Sodium hydroxide. Where do we use sodium hydroxide? We use it in the process called saponification, formation of soap. Formation of soap. And two, sodium hydroxide, we use it also in formation of detergents. Formation of detergents. Detergents. Okay. Now, there is a situation which I've ever seen where they told you to know the properties of these products from the membrane cell. This one you'll read on your own, but let me help you here. One of the properties of hydrogen is that it burns with a pop sound, and yeah, it burns with a pop sound. It's combustible. Chlorine is poisonous. Actually, both these uses are based on that property. Sodium hydroxide, it is basic in nature. So if they go that side, I wish you can recall what I've just told you. Kind of thanks. And please don't forget to subscribe. The channel is called Physical Sciences Silver Bullet, and it's Richard behind the channel.